As promised, we are going to be looking at visuals of these vertical and horizontal asymptotes. They are already drawn in on our first couple of graphs, but we need to label them and identify them. So if we look at the up and down ones first, remember that those are vertical. We have one right here at x equal to -1 because it went through -1. Our vertical asymptote, therefore, is -1. Notice on the left-hand side, when we approach the asymptote, our y value shoots up to the sky. And on the left-hand side, when we approach the asymptote, it shoots down to the ground. Our vertical asymptotes make our y values go really, really high or really, really low. And then we get a look for our horizontal lines. Remember, horizontal lines are flat. And this one is already in here. Okay. We have a horizontal asymptote of y equal to, and it goes through the y value of 2. So our horizontal asymptote is y equal to 2. Looking at our next example, starting with vertical asymptotes, we have 2 instances where it seems that our y values on our graph are going crazy as we approach these vertical lines. So we're going to have 2 vertical asymptotes. The first one is on the y-axis. This is where x is equal to 0. The second one is in between 2 and 4. That's when x is equal to 3. So vertical asymptotes, we have 2 of them. X equal to 0, x equal to 3. Our horizontal asymptote, where is our graph flattening out? So it starts running, but horizontally, like it's on the road. Here we go. And notice that to the right, our x values get as close as we can. To the left, our x values get as close as we can, but we don't cross the horizontal asymptote. Same thing with the vertical. We get as close as we can, but we don't cross them. And here, since we're on the x-axis, we have y equal to 0 as our horizontal asymptote. In our next example, they're not labeled. So we need to find them. All right, so looking at our graph, we're looking for where the y values go really high or really low. If you notice, it looks to be a line right here, because on the left we're going down, on the right we're going high. So that's an x equals. And this time our graph is going by 2's. So moving over, because 1, 2, 3, 4, 5 gets us to -10. So it's counting by 2's. We have a vertical asymptote of x equal -2. Our horizontal asymptote, remember horizontal line, we need where our graph is flattening out. And it looks to be happening about here. So we're going to have a y equals. And it's in between 0 and 2. And it looks about halfway in between. So we're going to say y equal to 1 is our horizontal asymptote. Looking at our next one. Identify our vertical first. We have 2 of them. We have one occurring on the left. We have one occurring on the right. Now let's figure out the values. This time the graph is going by 1 each block. So 1, 2, 3, we have x equal to -3 as our first vertical. And on the right-hand side, x equal to 2. Okay. Now we need to find if we have a horizontal asymptote, where are we flattening out? Kind of going right here. You can notice on the left-hand side, our graph gets super close but doesn't cross. The right-hand side, same thing, flattening out. The middle child never really pays much attention to what everybody's doing, so they will cross over. It's okay, but the outsides will not cross over your horizontal asymptote. And since we are flattening out near y equal to 0, we have a horizontal asymptote of y equal to 0. Finding the slant or oblique asymptote, this is another example of the polynomial long division, and then we'll discuss how to sketch it on the graph. So we need it in descending order. The denominator goes on the outside. The divisor, the numerator, the dividend, the numerator goes on the inside. And we can begin. Remember that we are only concerned with the first term of the outside and the inside. So what do I need to multiply x by to get x squared? Well, I need an x. I'm going to put that in my x column. My next line is going to come from x times my divisor, the x minus 3. When we distribute, we're going to have x times x, which gets me x squared. X times -3 gets me -3x. We're done with the multiplication through, so we change the signs when we draw the line. First term cancels. If they didn't, something went wrong. Go back and fix it. X plus 3x gets me 4x, and I bring my next term down. And then we start over, but this time we're looking how many times does x go into 4x, or what do I need to multiply x by to get 4x? I need a positive 4, so I'm going to write plus 4. And then my next line comes from 4 times my divisor of x minus 3. Distribute the 4 through, so we're going to have 4 times x, which is 4x. 4 times -3 gets me -12. Change the signs when you draw the line. Add vertically. -6 plus 12 gets us 6. Remember that that guy is our remainder. And we're really only concerned about the top. We have a horizontal asymptote. Oh, sorry, not horizontal. We have a slant or oblique asymptote of y equal to what's at the top, x plus 4. Remember that this is in the form y equal to mx plus b. So when you need to graph this guy, where you need a slope of 1 over 1, and b is our y-intercept, which in this case is 4. So when I'm graphing this, I'm going to start at y-intercept of 4, and then my slope is my map, my rise over my run. So I'm going to go up 1 over 1, up 1 over 1. And I can do that all the way across the graph. Up 1 over 1. And you just keep on going. And notice that our graph gets closer and closer to our slant or oblique asymptote as we go to the right. To do the back side, we need to work backwards. So instead of going up 1 over 1, we're going to go down 1, back 1, down 1, back 1, and we're going to keep doing this throughout the rest of the graph that we have. And notice that our graph gets closer and closer to this vertical, try that again, to this oblique asymptote. And I can connect it with some lines. And then of course, since we're going to be practicing graphing, go ahead and label this. This is y equal to x plus 4, our slant or oblique asymptote. Remember, with our asymptotes, our graph will get as close as it can without crossing. And then our values of x or y get really big or really small.